Hello, my fellow organic chemists. Today, I have an exhilarating presentation for you on the Hofmann and Cope elimination, named after these two dead white guys on the screen. First, we have the Hofmann elimination, and I'm sure a lot of you are familiar with elimination reactions, and the Hofmann elimination in particular has this alkyl ammonium ion as the leaving group. Now, this can be prepared from primary, secondary, and tertiary amines by treating with excess methyl iodide. And then once you form that ion, you just treat it with strong base. It's usually silver oxide and heat, and then you get elimination. And it turns out you actually only form one of these products, and it's the less substituted one. And now, why does that occur? If we look at Newman projections of the two possible transition states, the Zaitsev forming the right product and the Hofmann forming the left product, we see that the Zaitsev has gauche interactions right here between the leaving group and this methyl group right here. And because the alkyl ammonium ion is pretty sterically hindered, this will actually prevent it from leaving. But when you look at the Hofmann side, you can see that the carbons are over here in this ethyl group and they're much further away from the leaving group, and that allows it to leave much more readily, and thus you only form this less substituted product right here. Now, if we take a look at the mechanism is actually pretty straightforward. Once you treat it with metal iodide and form that alkyl ammonium ion, the base will pick up the proton, the electrons will go down, the electrons will hop to the nitrogen, it'll eliminate, and you're left with your less substituted product. Now, the other reaction we have is a Cope elimination. And this reaction is very similar to the Hofmann elimination, but it has a different leaving group structure. With this case, the leaving group is a tertiary amine, and when it's treated with hydrogen peroxide or other peroxy acids such as MCPBA and then also heat, it eliminates. And it turns out it also eliminates in this Hofmann arrangement where the double bond is in the less substituted position. Now, if we look at the mechanism for this reaction, once you have a tertiary amine, that nitrogen can pick up the oxygen, and once that is deprotonated, then you form this kind of Zwitter ion where you have the negative charge and the positive charge. And so this oxygen is actually what deprotonates the hydrogen and allows for the elimination to occur. Now, it's very important to note that this is a syn elimination where the proton that is being deprotonated is on the same plane of the molecule as the leaving group. So in this case, it's facing towards, and the proton is doing the same. And that's because just like the alkyl ammonium ion, this N oxide is pretty sterically hindered. So because of that, it'll form the Hofmann product and will only take a proton that's on the same plane as it. And then once you take the proton, you get this hydroxylamine and you get the eliminated product. Now, let's take a look at a practice problem and see if you can tell the difference between the two reactions and guess whether it's Hofmann or Cope. I'll give you a second. Pelkey, if you want, you can pause the video. Okay, you probably paused it. So I'm going to tell you the answer, and it's Hofmann. Now, why is it Hofmann? Basically, the difference between these two and what gives it away is the reactants. So the silver oxide is a pretty big indicator that's a Hofmann, and additionally, instead of treating with hydrogen peroxide to form that N oxide, you're treating it with excess methyl iodide in order to form that alkyl ammonium ion. I hope you guys learned something. Thank you so much for tuning in, and I really appreciate your hard work and listening to my hard work. Thank you.